Hi everybody. In the previous chapter, in chapter 7, we calculated the value of a bond. Remember, there were two main sources of financing for a firm, either through debt, through bonds, or through equity, through stocks. Now, in chapter 9, we are going to calculate a valuation of specific stocks. So we are going to value the stocks. Now that we valued bonds, we are going to continue, not this week with chapter 8, but in next week we are going to calculate valuation of the bonds. For us, in order to be able to do that, we need to calculate the risk premium for stocks. So this chapter is kind of dedicated to understanding, okay, what is going to be my risk based interest rate for stocks, for equities. Remember, for bonds, what we had was, okay, the interest rate that I'm going to demand, it's sometimes called RD, or yield to maturity, is the real risk-free interest rate plus inflation premium plus default risk premium, liquidity premium, and maturity risk premium. This was the interest rate to calculate the bonds, yield to maturity. Now, for stocks, it's going to be different. First of all, we need to calculate the risk associated with a stock, and then add that risk premium to risk-free rate to be able to calculate the total return demanded on a stock. That is going to be our interest rate I in stock valuation, and we are going to have the present value, which is the current value of the stock, payments, which are the dividends, and some assumptions about future value. So that's kind of chapter 9. But again, in order to calculate the value of the stock, we need to calculate the quote-unquote interest rate, or the required rate of return for a stock, and that is based on the risk. There is standalone risk and portfolio risk, and we are going to see that portfolio risk is what it actually matters when we are calculating the value of a stock. Now, if you look at these two graphs, you are going to see that the probability of losing value, which is denoted the area under the red curve, is greater than the probability of losing money under the blue curve. So the red curve, from that perspective, is riskier. They have the same expected return, so the average is the same. One is wider, this one is wider, and the other one is narrower. That means this particular one, for Y, standalone risk, is higher. So there is a relationship between standard deviation, which is the shape of the curve, how wide the curve is, and the riskiness of the portfolio, as demonstrated here. When we look at empirical data from 1926 to 2013, we are going to see that the average return of US Treasury bills is the lowest, but at the same time the standard deviation of these Treasury bills is lowest too. So low risk, low return. And then we are seeing, as we go higher, we are seeing that the average return increase as the standard deviation increases. So that means the riskier the stock or an investment, the higher average return is demanded from those stocks. And small company stocks deviate the most, and the expected value or the required return on those stocks is the highest. We can plot these curves. T-bills are pretty much, there is no standard deviation. We are going to take T-bills as risk-free rates. Why are they risk-free? Because they are very short-term. The only variability in those is pretty much the inflation premium that they get. So what we are going to take T-bills as risk-free, as a proxy at least for risk-free. As I mentioned earlier on the graph, the standard deviation is a measure of risk. It's not a great measure of risk, but it actually explains at least the standalone risk itself. Now, in a portfolio, when we are looking at the portfolio risk, and as we are adding more and more stocks, so this one says number of stocks in a portfolio, and this one is the standard deviation of the portfolio, you are going to see that is going to go down. It's not going to go down to zero, but it's going to go down to a specific level. This piece is called the market risk that you cannot avoid by diversifying. This piece is diversifiable risk, and you are expected to diversify and include different stocks in your portfolio, and hence this risk is assumed to be you can eliminate, and this risk is what's called systemic or market risk. Now, standalone risk is market risk plus diversifiable risk. This again is what we are expecting. It needs to go to zero. You need to diversify. You cannot hold just one single stock. You want to make sure that you diversify. Now, there are different methods to calculate the actual required rate of return, which is pretty much the essence of this chapter for a particular stock. Overall, it is risk-free rate plus some risk premium. Now, the required rate on a stock is again risk-free rate plus the risk premium. What the CAPM model says is the risk-free rate is given. It's usually the T-bills rate. And then there is something called beta, which is the correlation between the stock, how the stock moves versus how the market moves, and the difference between the market return and the risk-free rates. We are going to go over these in specific examples, but RI is the quote-unquote interest rate or the required rate of return from a stock. This is risk-free rate. This is market rate, market return, and beta is how the stock fluctuates with the fluctuations in the market. The relevant risk assumes it's going to be beta. So when we calculate betas, we are regressing the lines of the individual stock and how the market performs. For example, in this case, if the market is performing at 12%, the stock is performing at 15%. So there is some augmentation, so to speak, and the slope of this regression line between the individual stock versus the return of the stock versus the market return of the stock is what is called the beta. So what do we need to do when we calculate beta? For example, if the risk-free rate is 5.5% and if the market is overall average is 10.5%, then the risk premium turns out to be 5%. So this is 10.5 in this example. RF is 5.5. Risk premium is 5%. If my beta in this case is 1.32, what I need to do is multiply the difference 5% by 1.32 and add the risk-free rate. This is the risk premium I am calculating based on beta. As you see, as it fluctuates less and less, it is considered less riskier and less riskier, and hence the required rate of return diminishes. Now, I want to do this with an important caveat, which is this is not the only way to calculate the required rate of return on a stock. It's one of the ways. It has its kind of errors and contradictions on cons, but this is widely used as a method when you are calculating the required rate on a stock. And when you go to Yahoo Finance, for example, you are going to easily find the beta of a specific stock, you will be also given the market return and excess market return. So whatever the percentage is historical average is over risk-free rates, and hence you can calculate, quote unquote, again, the interest rate for a stock in stock valuation when we use the time value as an example, or the required rate of return on a stock, again, which we are going to use in the next chapter. This is pretty much what I want to cover under this chapter. And again, in chapter 9, we are going to take these and plug them as interest rates, and we are going to calculate and find out how to value stocks using time value of money operations.